Assalamu alaikum students. This is the time value of money video lecture series part 4. Right. So today we will solve some ordinary annuity problems, and then we will move forward to we will solve some annuity due problems. Right. So I will gonna solve some problems from practice set 1. Time value of money practice set 1. I have already given this one to you. In this practice set 1 you will find some solved question set. So let us start with question number 15. From annuity examples we will solve some annuity example, as I said before. So let us start with question number 15. How much should you pay per month to borrow 2.5 million taka now to purchase a Toyota Premio car if bank charges 16% interest compounded monthly on a 5 years loan? Right. So that means you want to borrow today. If you want to borrow 2.5 million taka to buy that Toyota car on a 5 years loan, in that case how much should you pay per month? So that means what should be the monthly installment for the loan? So if you borrow 2.5 million taka today on a 5 years loan, in that case what should be the monthly installment over the 5 years period? That's the question is asking us to find out. So let me show you the time diagram here. So suppose this is the time diagram. So today is period 0. You have borrowed 2.5 million taka. So 2.5 million taka. So you have borrowed 2.5 million taka, which is 25 lakh taka or 2,500,000 taka. Right. So that means you have borrowed this amount of money today. Right. So you have borrowed this amount of money today, and after 1 month you will, let's see, this is your monthly installment amount. So after 2 months again this is your monthly installment amount. After 3 months again this is your monthly installment amount, and like that way up to 5 years. So that means up to 5 years you will gonna pay your monthly installment. So 5 years. So 5 years means we know that in every year we have 12 months. So that means total 60 installments. So that means total 60 installments. So total 60 installments. Now that means this is annuity, because you have here multiple payments are there or multiple installments are there. So this is annuity, and let us assume that this is ordinary annuity, because it doesn't say that whether the payment will be made at the beginning of the period or at the end of the period. So by default we will assume that this is ordinary annuity. That means we will assume that payment will be made from the end of the month. Right. So that means after 1 month you will make your first payment. So this is ordinary annuity problem. Right. So this is annuity, there is no doubt about that. So that means this is the amount you have borrowed today. So this amount you will need to pay it off by these monthly installments. That means the present value of all these future cash flows. So that means the present value of all these future cash flows should be equal to this amount. So that means the present value of all these future cash flows. So that means present value of all these future installments. Present values of all these future installments should be equivalent to 2.5 million taka today. Right. So the present value of this annuity is given. So this is the present value of a full annuity. So this is the annuity, and the present value of this annuity is 2.5 million taka. We just need to find out the value of C. Right. So the present value of annuity we know. So the formula. So that means we need to use, since the present value of annuity is given, we need to use the present value of annuity formula, and this is the present value of annuity formula. 1 minus here 1 plus R bracket power minus T. So this is the present value of annuity formula, right? So we need to find out the value of C, that is monthly installment, right? So let us do cross multiplication. So if you do cross multiplication, in that case P will be multiplied by R, and we will be left with C multiplied by bracket this one, right? So P is the present value of annuity. So P is the present value of annuity, and in this case 2.5 million taka. So P is the present value of annuity, which is 2.5 million taka multiplied by R. So R is, the question said that R is 16% compounded monthly. R is 16% compounded monthly. So 16% is the annual percentage rate or annual rate, but it will be compounded on a monthly basis. So we need to convert this one to monthly rate. So 16%, that is 0.16, is the annual rate. So but since the interest will be compounded on a monthly basis, so we need to find out the monthly rate. That means we will divide it by 12, right? Is equal to C bracket 1 minus bracket 1 plus this one. So 1 plus this one, bracket closes there, power minus t, minus t. So t is here, we have total 16 installments. So t is 5 years. So 5 years, in 1 year we have 12 months, so total 16 installment or 60 months, right? So power minus 60, right? So first of all, let us do this multiplication. Let us do this. We will multiply this one, right? So 2500 multiplied by 0.16 divided by 12, right? So 2.5 million, that means 25 lakh taka multiplied by 0.16 divided by 12. So let me do this one. Right, so I will use this calculator to solve it. So 2.5 million, that means we will have total 5 zeros there, right? 1 2 3 5 zeros, 1 2 3 4 5, right? Multiplied by I will get a fraction there. So this is the fraction button. This is the fraction button from your calculator. So I will get the fraction button there. So divided by 12, right? So if you type it like this way, you should get the answer, which is like that, right? So the answer is 3333.3333, right? Is equal to C, and now let us calculate this one. Let us calculate this portion, right? So if you calculate this portion, how should you do it? Right? So again I will use this calculator. 1 minus bracket. So listen. So 1 minus, and then we have a bracket there. So 1 minus, and then we have a bracket there. So since we have a bracket there, we will put a bracket in the calculator as well. And then inside the bracket we have 1 plus. Inside the bracket we have 1 plus, and then we will get a fraction 0.16 divided by 12, bracket close, power minus 60. So power minus 60. So I have shown you how to type these things in my previous video lecture series. In my previous video lecture, I have shown you how to type it like that way in the calculator. So if you type it like that way in your calculator, you should get this answer. So 0.548289, right? So 0.5482 So right, so now C is equal to what? So that means if you bring these one to left hand side, so it will be divided. So that means it will be in the lower part of the fraction. That means it will go into the denominator, right? So that means C is equal to this one divided by this one. So this one is already in the answer because we have just calculated it. We have calculated it. This one is already in the answer. So what you just need to do, you just need to press this one. So let me show you. So I will just, so this is already, the previous answer is already in the calculator. What I will do, I will just press this one. I will just type this one in my calculator. I will just type this one in my calculator. So I will just type this one in my calculator. So first of all, I will type that one in my calculator. So let me type. So 33333.33333, right? So like that way I will type it, and then divided by answer button. So if you press divided by answer button, you should get the answer. So that is the answer, 60,795.1427. So 60,000. So the answer is 60,795.1427, right? So this is taka, right? So that means if you borrow 2.5 million taka on a 5 years loan to buy that car, in that case you need to pay 60,795.1427 taka at the end of every month, and like that way total 60 in installment over the 5 years period to pay off the loan, right? So that's the answer, 60,795. Here I got 60,775. Why? Little lower, I got little lower because you may get little higher or little lower because of the figure that you have actually used here, because here I have used only 54846, that means up to 5 decimal point, right? But when I have done the calculation now, I have actually used the full figure. That's why, right? So little fluctuation might be there, doesn't really matter. So now the next part of the question is asking, find the amortization schedule for the first two payments. Find the amortization schedule for the first two payments, right? As I said in my previous video lecture, that what the bank will do, they will use amortization schedule to calculate your interest and calculate your loan balance, right? So that means at the end of first month, this is your monthly installment, 60,775.38 taka. This is your monthly installments amount. Right? So that means at the end of every month you will pay 60,775 taka to pay off your loan, right? So by the time you will pay your first installment, that means at the end of 1 month, when you will go for first payment or first installment, so at the end of first month, when you will go for to make first payment of 60,775 taka, by that time 1 month is over. By that time 1 month has gone. So what the bank will do, bank will calculate that first month's interest. So what the bank will do, when you go for making your first payment of this amount by the end of 1 month, so by that time already 1 month is over, what the bank will do, bank will calculate 1 month interest. That means bank will calculate first month's interest, right? So this is the amount you have borrowed, and this is the amount you have borrowed, and this is the interest amount. This is the interest amount, monthly interest amount. How? Because this is the monthly interest rate, 16%. That means 16%. Let me show you. 16% is the 0.16 is the annual interest rate, and since the bank will calculate it on a monthly basis, so they will divide it by 12, right? So 0.16 divided by 12, 0.16 divided by 12, we will get 0.013333, like that, or we can write it like 0.1334, right? So this is the monthly interest rate. So this is the monthly interest rate. So this is the monthly interest rate. So monthly interest rate is this one. So what the bank will do, so this is the monthly interest rate. This is the monthly interest rate. So by the time you will go for your first payment at the end of 1 month, 1 month is over, bank will calculate your first month's interest. This is the amount you have borrowed, and this is the monthly interest rate. So if you multiply these one, so this is the first month's interest. So this is the first month's interest amount. So what the bank will do, this is the amount you are paying, this is the amount you are paying, this is the first installment, this is the amount you have paid, and from that amount they will deduct the interest amount. They will deduct the interest amount. So that means this is the due interest amount. So they will deduct this interest amount from these amount. So after deducting, after they will deduct it, this is the amount you have paid for your first installment, and this is the interest amount. So and remaining amount will be used to reduce the loan balance. So this means this is the amount your loan balance will be reduced by. So your loan balance, initial loan balance, this is the amount you have borrowed, and from that one these amount will be reduced. These amount will be reduced. So which means loan balance, so this is the amount it will be reduced by, and new loan balance, this is the new loan balance. So that means you have paid out of this 60,775 taka, you have paid this amount as interest, and you have paid this amount to clear the loan balance, to clear the or to pay off the loan. So this is your new loan balance. So after second month, when you will go for your second installment, so after second month when you will pay your second installment, by that time again 1 month is over. By that time again 1 month is over. So what the bank will do, bank will calculate second month's interest rate, interest amount. So bank will calculate second month's, so bank will calculate interest amount for the second month. Bank will calculate interest amount for the second month, and loan amount is no longer this one. So now the new loan balance, this is the new loan balance, because you have already paid off this much amount of loan. Because you have already paid off this much amount of loan, this is your new loan balance. So bank will calculate interest amount for the second month like that way. So this is the new loan balance for the second month, and this is the monthly interest rate. So if you multiply these one, you will get 32,984. So this is the monthly interest, this is the interest amount for the second month. This is the interest amount for the second month. So and this is the amount, monthly installment amount you have paid, and this is the interest amount. So if this is deducted from this one, so this is the amount you have actually paid off the loan. So this is the amount you have paid off the loan. So previous loan balance was this one, and from that one you have paid off this much amount of loan. So that means from this one, this 27,791 will be deducted. That means from this one will be deducted. So this will be the new loan balance. So bank will calculate amortization schedule like that way for the remaining, for all the 60 payments. I have just shown you two amortization schedule for the first two installment, but what the bank will do, bank will calculate amortization schedule for all the installments like this way. Right, so question number 16 is exactly like question number 15. You can easily solve it at your home and easily find out the amortization schedule like before. Right, so question number 16 is similar like question number 15. Please solve it at your home. Right, now I will show you question number 17. So what we have in this question, Miss Nasreen has opened a deposit pension scheme account. So Miss Nasreen has opened a deposit pension scheme account with a bank in Bangladesh that is offering 12% interest compounded monthly for a 5 years maturity account. So Miss Nasreen has opened a DPS account or deposit pension scheme account with a bank in Bangladesh that is offering this interest rate for a 5 years account, 5 years maturity account. So question is asking, if she is depositing 500 taka per month on the account, then how much she should receive at the end of maturity. So how much she should receive at the end of the maturity. So it doesn't say whether she will pay 500 taka at the end of each month or at the beginning of each month. It doesn't say anything like that. So let us assume that this payment, let us assume that by default we will assume that this is ordinary annuity. That means we will assume that she is paying this monthly installment at the end of each month. So that means after 1 month she will pay 500 taka, after 2 months she will pay 500 taka, and like that way up to 5 years. Right, so that means this is the monthly payments or monthly installment. So she is depositing 500 taka per month. She is depositing 500 taka per month. That means at the end of each month she will pay 500 taka. So in 1 year total 12 payments, in 5 year total 60 installment or 60 payments of 500 taka each. So which means this is clearly annuity because lots of installments of 500 taka is there, right? So this is clearly annuity. The question is asking how much she should receive at the end of maturity. How much she should receive at the end of maturity, right? So that means let me show you the diagram. Right, so today is period 0. After 1 month she will pay 500 taka. After 2 months she will again pay 500 taka. After 3 months she will pay again 500 taka, and like that way up to 5 years. Up to 5 years means total 60 installments. So 60 months. So up to 5 years. So up to 5 years. So 5 years means in 1 year there is 12 months. That is 12 installments. So total 60 payments or 60 months. Total 60 payments or installments. 60 payments or 60 installments of 500 taka each. Now the question is asking what will be the future value of all these cash flows. So question is asking what will be the future value of all these cash flows. So that means we want to find out the future value of all these cash flows. That means what should be the amount you should receive at this period. So right, so that means what should be in the account after the last deposit is made. So what should be in the account? The question is asking how much should be in the account at the end of the maturity or at the time of last deposit. So how much should be in the account at the end of the maturity, that means after 5 years. How much should be in the account at the end of the maturity, that means after 5 years, that means after the last deposit is made. So we need to find out the value or the account balance that we will get at this period. So that means we need to find out the future value of all these cash flows at this period. So we need to find out the future value of all these cash flows at this period. So obviously future value we need to find out, right? So future value you need to find out. So we will use future value formula. We will use future value formula, which is equal to C divided by R bracket 1 plus R power T. Power should be now positive. Minus 1. Right, so minus 1. Now let us calculate C. The value of C, monthly installment, is 500 taka. Monthly installment is 500 taka. So C is 500 taka. So C is 500 taka is given in the question. R, rate of interest. So rate of interest, let's check out. Rate of interest is 12% compounded monthly. So 12% compounded monthly. So 12% rate of interest is 12% is the annual rate, and if you want to get monthly interest rate, you should divide it by 12. Bracket, another bracket, 1 plus R. R means this one. Bracket closes there. Power T. So power T means total 60 installments are there. Total 60 installments. 5 years, 60 payments. 5 years, 60 months. That is 60 installments are there. So 60. And then minus 1. Bracket closes there. So we can do this directly using calculator, as I have shown you before. Let me show you again. So you can do it directly in your calculator. So first of all we will get a fraction. So this is the fraction button in your calculator. So if you press this button, you should get this one. So press 500 and after you press 500, you should go to the denominator, lower part of the fraction. So what you can do, you can press this button to go to the denominator, or you can press this one as well. to go to the denominator, or you can just touch there. This is a touchpad. You can just touch there where you want to type. So I have just touched it, right? So here we need to get now the cursor is in the lower part of the fraction, but in the lower part of the fraction I need to get another fraction. I need to get another fraction there. I need to get another fraction in the lower part of the fraction. So that means I should get another fraction there. That means I will press this fraction button again. So to get another fraction in the lower part of the fraction. So now I will gonna press 0.12. Now I will again go to the lower part and then this one. So now as you can see, the cursor is in the lower part of the fraction. So I should type here. So I will just touch there. See, I have just touched there. So cursor is there now. Now I need to get a bracket there. So now first of all I need to get a bracket for this one. So I will get a bracket for this one, and then I should get another bracket for this one. So another bracket for this one, right? Like that. And then what we have? 1 plus. So 1 plus, and then there is a fraction there. So there is a fraction there, 0.12 divided by 12, bracket close, power 60 minus 1, bracket close. Right. So if you type it like that way, you can get the answer directly. Right. So the answer is this one, right? So the answer is 40,834.8349 taka, right? So the answer is 40,000. Answer is 40,834.8349 taka. 8349 taka. So that means after 5 years, you should get 40,834 taka from the account. Right. So after 5 years, you should get this much amount of savings from your account. Right. So you can do it also in different way. First of all, what you can do, 0.12 divided by 12, that is 0.01. You can write also 0.01. Again, here also 0.12 divided by 12 is 0.01. You can write it like that way. So in that case, again you can solve it to get the answer. Right. So so that means Miss Nasreen will get this much amount of savings or this much amount of taka at the end of 5 years. Now the second part of the question. Is asking that if she needs to borrow the maximum amount, that is 90% of the accumulated value of money she can possibly get from the account, from the bank against her deposit DPS account after 3 years from now. So question is asking, for example, after 3 years. So she has started the DPS account by making her deposit, but after 3 years of depositing the money, after 3 years, now she need to get some money. She needs some urgent money. So after 3 years, she has realized that she needs some money urgently. So she can borrow the money. Borrow money from the bank against her DPS savings. So that means she has already some savings in the DPS account. So what she can do, she can do two things. She can break the DPS account and get the savings. So remember, condition of DPS account is if she break the DPS account, she won't get any interest amount. She will only get the amount she has saved. That means if she, after 3 years of saving, if she break the DPS account before maturity, she won't get any interest. So she has decided that instead of breaking the DPS account, she will borrow some money against her savings in the DPS account. So instead of breaking the DPS account, instead of closing the DPS account, she will borrow some money from the DPS. She will borrow some money from the bank against her DPS account. So bank said that bank will pay maximum. Bank said that she can borrow maximum 90% of the accumulated value. That means she can borrow. Bank said that Miss Nasreen can borrow maximum 90% of the total savings until up to 3 years, right? And bank will give you loan against that DPS account. Bank will charge 16% interest compounded monthly, right? Then the question is asking that how much she should pay per month to pay off the loan. Amortize means pay off the loan. So the question is asking how much Miss Nasreen should pay per month to pay off the loan amount by the end of DPS account. Right? So let me show you. Let me explain these one using a diagram. So here, after 3 years, this is period 0. So after 3 years, of saving, you need to borrow some money against the DPS account. So after 3 years of depositing money in the DPS account, you have decided to borrow some money against your savings in the DPS deposit account, and so that means we need to find out first how much you have saved. So we need to find out the future value after 3 years. That means we first need to find out how much you have actually saved over the 3 years period. That means how much is your account balance at this period. So how much should you get from the, that means this is the, we need to find out the total savings or total accumulated value after 3 years. So that means, so before we have calculated future value after 5 years. So now we need to calculate future value after 3 years. So now we need to calculate future value after 3 years. So let us calculate. So as you can see, after 3 years means total 36 installments. So 3 years means 36 installments. 3 years means 36. So in 1 year 12 installment. So in 3 years total 36 installments. So first of all, we need to find out the future value after 3 years. That means the total accumulated value after 3 years. All right, right. So this is the, so that means this is the what is that called? This is the value. This is power. If you use the power 36. That means 36 installments. If you use power 36 to find out the future value, the future value, that means the total accumulated value is 21,538.44 taka. So that means 21,538. So that means after 3 years your savings will be 21,538.44 taka. Right. So 21,538.44 taka. That's your, this is the amount you have saved over the 3 years period. Now, bank said that Miss Nasreen can borrow maximum 90% of these amount. So maximum 90% of the accumulated amount within 3 years. So after 3 years, she wants to borrow some money against her this accumulated amount. This is the accumulated amount after 3 years. So now she wants to borrow some money against this accumulated amount, and banks said that they can give maximum 90% of the accumulated amount. They can give loan of maximum 90%. They can give you loan maximum 90% of this amount. So that means this is the accumulated amount after 3 years, and she can get maximum 90%, which means these one multiplied by 90%. That means she can borrow this amount of money for the remaining 2 years period. So that means by the end of that means she can borrow the money. She can borrow the money at this period, but she needs to pay off the loan. She needs to pay off the loan within 2 years. She needs to pay off the loan within 2 years. So that means she can borrow this 19,384 taka. That means 90% of this amount. So she can borrow 19,384. So she can borrow 19,384.59 taka. 59 taka at this period. That means after 3 years. But she needs to pay off the loan within 3 years. That means by the time the DPS account mature, she needs to pay off the loan. So that means she will get only 2 years to pay off the loan. That means she will get only 2 years to pay off the loan. All right. So that means loan maturity is 2 years. Loan maturity is 2 years. Again, she needs to pay off the loan. She needs to pay off the loan by monthly payments. She needs to pay off the loan by monthly payments. So in 2 years, we will have total 12 months. That means 12 payments. Sorry, not 12. In 2 years, we have total 24 months. So 24 months means 24 installments. So that means she needs to pay off the loan by making 24 installments, so 24 payments. So she has borrowed, now she is borrowing this much amount of money. So for the loan amount, this is period 0. That means, so let us assume that she is borrowing the money today. Let us assume that she is borrowing the money, she is borrowing these amount. Let us assume that she is borrowing these amount of money today, and she need to pay off the loan within 2 years by making equal monthly installment, right? So that means we need to find out the value of C. And this is the present value of the loan. She needs to pay off the loan within 2 years. Let us assume that this is the present value of the loan, and she needs to pay off the loan within 2 years by making monthly payments. We need to find out the monthly payments for this loan, right? So present value of the loan, so the present value of the loan is, so the present value of the loan now is, so since the present value of the loan amount is given, this is the present value of the loan, and we need to pay off this loan by making monthly payments over the 2 years period, right? So that's why we will use the present value of annuity formula, right? So we already know the present value of annuity formula: 1 minus bracket 1 plus r bracket closes power minus t. Power in the present value formula, there should always be a minus. So let us do the cross multiplication. So we will be left with, in that case, this one, right? So the present value of the loan, so present value of the loan is 19,384.59. 19,384.59 taka is the present value of the loan, and the interest amount is 16%. This is the interest amount for the loan. So 16% compounded monthly. So interest amount is 16% compounded monthly. So 16%, interest rate is 16%. So 0.16 compounded monthly. So compounded monthly means divided by 12 is equal to C bracket 1 minus bracket closes there 1 plus this one, 1 plus this one bracket close power minus t minus t is equal to, we have 2 years maturity for the loan. So we have 2 years maturity for the loan. So we have 2 years maturity for the loan, that is 24 installments. So 24 installments, that means minus 24. So value of t is 24, right? Bracket closes there. So let's do this calculation first. So what will have? 19,384.59 multiplied by 0.16 divided by 12. So we should get 258.4612, right? So this is what we should get, right? And on the right hand side, what we will have is, right, C multiplied by, let us do this calculation. So 1 minus bracket 1 plus, let us get a fraction, 0.16 divided by 12 bracket close power is minus 24. So what we should get is 0.2723, right? So 0.2723, so which means C will be equal to this one divided by this one. This one divided by this one. So which means 258.4612 divided by answer button. So that means 949.1298. So this will be the monthly installment. So that means this will be the monthly installment. That means she needs to pay 949 taka at the end of every month for the remaining 2 years to pay off the loan. So that means this C amount. So that means this is the. Now let me show you the full diagram again. This is period 0. This is period 0, and she is at the end of each month she is paying 500 taka. She is depositing 500 taka in the DPS account, and like that way up to 5 years. 5 years means total 60 installments of 500 taka. This is the DPS account. Right. So this is the DPS account. Now after 3 years, so after 3 years she is now borrowing. She will borrow after 3 years. She will borrow 19,000. She will borrow 19,384.59 taka. So after 3 years she is borrowing this much amount of money. So that means she needs to pay off this loan within 2 years. So she needs to pay off this loan within 2 years. That means by the time DPS account matures. So at the end of each month, she will need to pay. So she will need to pay 900. So at the end of each month she will need to pay 949 taka, 49.129 taka at the end of each month to pay off the loan. This is the installment amount. So that means again she also needs to continue paying 500 taka for the DPS account. So she also need to pay 500 taka at the end of every month to continue the DPS account. But since after 3 years she has borrowed this amount, she also need to pay off the loan. She also needs to pay 949 taka monthly installment to pay off the loan amount. So that means after 3 years, she at the end of every month she needs to pay this amount to pay off the loan and 500 taka deposit to continue the DPS account. Right. So let's solve question number 18 from the practice set 1. So what we have in this question, Mrs. Parveen has opened a DPS account with Southeast Bank by making her first deposit of 500 taka today. So pay attention. So Mrs. Parveen has opened a DPS account. Why I am using all the female name here? Because females, that means you will see that most of the DPS account, if you go to bank, you will see that most of the DPS account is owned by or opened by females. That means you will see that your mom, your sister, or your neighboring aunties will have DPS accounts. Normally females have more tendency to save, right? So Mrs. Parveen has opened a DPS account with Southeast Bank by making her first deposit of 500 taka today. So that means at the end of every month she will pay. This is a DPS account. That means you need to pay on a monthly basis. So this is a DPS account. That means you need to pay on a monthly basis. That means you need to deposit on a monthly basis. So she is depositing. She has deposited her first payment today. So that means the annuity is starting from today. So this is annuity due. So this is annuity due. So this is the first payment is not starting at the end of 1 month. Instead of starting at the end of 1 month, the first payment is starting from the period from today. So first payment is starting from period today. So that means at period 0 you are making your first payment. So annuity is starting from the beginning of the period. Annuity is starting from the beginning of the period, which means this is annuity due, right? So if the maturity of the DPS account is 10 years and provides an interest rate 12% compounded monthly, how much she will receive after maturity? How much she will receive after maturity, right? So how much she will receive after maturity? So let me show you the diagram. So at period 0 you are making your first payment of 500 taka. At period 1, that means after 1 month you will again pay your pay 500 taka. After 2 months you will again pay your 500 taka. So like that way total installment will be what? So this is a 10 years account. This is a 10 years account. So 10 in every year, there you need to make 12 installment. In 1 year we have 12 months. That means 12 installment. That is total 120 installment should be there. So total 120 installment should be there. But since the annuity is starting from period 0, since the annuity is starting from today, so here we will have 119, because 1 2 3 and like that way total 120 payments plus the first payment, right? So here the period will be 119, so 500. But since you are paying on a monthly basis, but since the annuity is starting from period 0, so here you need to find out, the question is asking how much you will get after maturity. So that means we need to find out the future value of all these cash flows. So we need to find out. So question is asking how much she should receive after maturity, and this is the maturity period. The question is asking how much she should receive after maturity. So how much she will get at this period. That means the future value. There is no doubt that this is annuity. We have no doubt about that, because multiple cash flows are there, annuity, and we need to find out how much she should receive after maturity. This is the maturity period. So that means we need to find out the future value. And so it doesn't matter what number you have here. You need to consider that how many cash flows are there. So these are here we have total 120 cash flows. Here we have total 120 payments. So we need to find out the future value of 120 payments. So we need to find out the future value of 120 payments. So the future value will be is equal to C divided by R, 1 plus R power T minus 1. So as usual, C is what? Monthly installment amount is 500. Interest amount is what? 12% compounded monthly. 12% is the annual rate. But it will be compounded on a monthly basis. So in one, we need to get the monthly rate. This is the annual rate. We need to get the monthly rate. So we will divide it by 12. So 12% divided by 12, that is 1%. So 1% is the monthly rate. So we can directly write 0.01 here. So again 1 plus 0.01 power t. So t is total 120 payments minus 1. So if you calculate, you should get the answer. So let me calculate it for you. 500 divided by 0.01 bracket 1.01 power 120 minus 1 bracket close. So that means we should get, let me check it again. Yes, right. So we should get 115,019.34447 taka after maturity. That means she should receive, Mrs. Parveen should receive 115,019 taka 34 paisa after 10 years of savings. So after maturity she should get these amounts. So this is the amount she will receive at the time of last deposit. So this is the amount she should get at the time of last deposit. So that means at the time of maturity. I'm repeating again. So this is the amount she will get from the account at the time of last deposit, at the time of last deposit or at the time of maturity. But if the question asks you that how much she will get after 10 years, so if the question asks you that how much she will get after 10 years, so if here the question asks you that how much she will get after maturity, and we already know, I have already shown you, this is the maturity period, this is the maturity period, right? But if the question asks you that how much she will get after 10 years, if the question asks you how much she will get after 10 years, right? So since the payment started, so for example, if you pay your first installment at 1st of January, so in that case at December 1 your last payment will be there. So you will make your last yearly payment at December 1. That means account will mature at December 1. Account will mature. For example, you want to save only 1 year. So if you pay your first installment at January, 1st of January, that means 1st of January, if you make your first payment at 1st of January and second payment 2nd of January, 2nd of February, third payment on, or sorry, if you make your first payment on 1st of January, second payment 1st of February, third payment 1st of March, and like that way up to, if you make 12 payments in a year, the last payment will be on December 1. So last payment we will make. That means account will mature on December 1. But if the question asks you how much you should get after 1 year, if the account asks you that how much you should get after 1 year, which means how much you should get on January 1 of the next year. January 1 of the next year. That means 1st of January of next year. So that means you need to go 1 month forward. So that means in that case, like for example, I'm going to show you again. Let me show you. Let me show it you in using a diagram. So for example, this is period 0, which is January 1. So January 1. So at January 1, Mrs. Parveen, she has made 500 taka deposit. Here, this is after 1 month, she has made again 500 taka deposit. That means February 1. At 1st of February she has made 500 taka deposit. After, at March 1, at the 1st of March she has made again 500 taka deposit, and like that way up to 10 years. Up to 10 years. So 10 years means total 120 installments. So as I said before, so these will be 119 because you have started from period 0. So since you have started from period 0, these will be 119, total 120 payments or 120 installments. So these will be again 500 taka. But here what will be the date here? So these will be December 1, because January 1, February 1, March 1, and like that way these will be December 1 of after 10 years. So for example, this is January 1 of 2020. This is January 1 of 2020. So these will be January 1 of 2030. So these will be January 1, 2030. Right. So that means, sorry, December 1 of 2030. So these will be December 1. So that means at December 1, 2030, you will make your last deposit. You will make your last deposit. So this is the future value of annuity. So future value of annuity, that means 115,000. This is these amount. So 115,019.3447 taka you will receive at December 1, 2030. So this is the date when you will make your last deposit. So at the time of last deposit, this is the time when the account mature. So that means at this period you should get this amount, future value of annuity, future value of full this annuity, future value of annuity you will get at period December 1, 2030. But if the question asks you that how much you should get after 10 years, if the question asks you that how much you should get after 10 years, so if the question asks you how much you should get after 10 years, which means in that case, if the question asks you how much you should get after 10 years, so that means since the account started from January 1, that means the question in that case the question is asking how much you should get in January 1 of next year, that means 2031. That means January 1, that means after 10 years, that means you need to go 1 month forward. So in that case you need to go 1 month forward, that means you need to go 1 month forward, right? So that means, so in annuity due problem, in annuity, since you have started 1 month before, so since you have made your first payment today, so in that case you need to find, if you want to find out how much you should get after 10 years, you need to go 1 month forward. That means if you want to find out the future value, at this period, that means if you want to know how much you should get, not 31, yes, 31. So if you want to know that how much you should get at this period, if you want to know what will be the future value at this period, in that case you need to move this amount 1 month forward. So if you want to move this amount 1 month forward, in that case, now this is a single amount, this is a single cash flow or single amount. If you want to move this amount from December 1, if you want to move this amount from December 1 to January 1 2031, that means 1 month forward, or if you want to move this amount from 1 month forward, in that case you have to use this formula, because this is not annuity, this is a single cash flow. Now this is the single cash flow. Now you want to move this cash flow to 1 month forward, 1 month forward. So in that case we will gonna use this formula. So this is a single cash flow. We will multiply it by interest rate. Is, we already know interest rate is 12% compounded monthly. This is the interest rate, 0.01. Power will be 1. Power will be 1 because you are moving 1 month ahead. So you are moving 1 month forward. Sorry, you are moving 1 month forward. So you are moving, since you are moving 1 month forward, power will be 1. Right. So power will be 1. So 115,019.3447 multiplied by 1.01 power 1. So which means the value you should get at January 1 2031. So the value you should get at January 1 2031 is equal to, so the value you should get at January 1 2031 is equal to 116,169.538 taka. Right, so this is the amount you should get. Right, sorry, I need to make a correction here. It will not be 2030, it will be 2000, it will be like here the date will be 2029, right? So that means, so at this period you will get your future value of annuity. That means this is the period where you at December 1 2029 you will make your last deposit. So that means 10 years, that means 120 installments. 10 years, that is 120 installments. So the last, if you have started your first installment at January 1 2020, if you have started your first installment at January 1 2020, then and if you are making 120 installments at the end of every month, and if you are making total 120 installments, so the last deposit you will gonna make is December 1 2029. So that means the future value of annuity is this one, this value, the future value of annuity, that means this value you will get at period December 1 2029. So this is the December 1 2029 is the last period, is the period where the account matures. That means this is the period where you will get the future value of annuity. Now if you want to find out how much you should get after 10 years, which means how much you should get at January 1 2030. So if you want to get how much you should get at January after 10 years, after 10 years means how much you should get at January 1 2030. In that case you need to move 1 month forward. You need to move this amount. This is a single amount, single cash flow. You need to move this amount 1 month forward. So in that case, so this is the amount you will get at period January 1 2030. I will repeat again. So if you have started your first payment on January 1 2020, in that case, and if the account matures after 10 years, that means 120 installments, in that case December 1 2029 will be your last deposit, right? So at December 1 2029 you will make your last deposit, and future value of all these cash flows you will get that means future value of the annuity you will get at this period, at the time of last deposit, at the time of the account matures. The account matures at the time of last deposit. So that means the future value of annuity you will get at the time of maturity or at the time of last deposit, which is 115,019 taka. So this amount you will get at period December 1, 2029. But so that means if the question asks you that, if the question asks you how much you will get after maturity or after the last deposit is made or at the time of last deposit, in that case these will be the answer. So this is the amount you will get at the time of last deposit. But if the question says that how much you will get after 10 years, since you have started your annuity from the beginning of the period, since you have started your annuity at the beginning of the period, your annuity will end 1 month ahead. Your annuity will mature 1 month before. So after 10 years means since the account has started from January 1, 2020, so after 10 years means if the question is asking how much will be in the account after 10 years, so which means how much will be in the account at January 1, 2030. So in that case, so what do you have to do? You have to move this amount. This is now a single cash flow. You will need to move this amount 1 month forward. So 1 month forward. So that means this is a single cash flow. In that case, we will use this formula. So P into 1 plus R to the power T. So this is the value we are moving 1 month forward. This is the value we are moving 1 month forward. So that means this is the amount we will move forward 1 month by 1 month. So 1 plus 01 power T will be, since we are moving only 1 month forward, in that case power will be 1. So this is the amount you will get at period January 1, 2030. Right. So now let us solve question number 19. If 8,000 taka, suppose for example 8,000 taka. So if 8,000 taka is deposited in an account at the beginning of each month, at the beginning of each month. So if 8,000 taka is deposited in an account at the beginning of each month for 10 years, So if 8,000 taka is deposited in an account at the beginning of each month for 10 years. So beginning of each month. So this is the monthly installment. So 8,000 taka is deposited in an account at the beginning of each month. So this is the monthly installment amount, but paid at the beginning of each month. Beginning of each month means this is annuity due problem, right? And the account earns 7% compounded monthly, How much will be in the account after the last deposit is made? Which means, so let me show you the diagram again. It's like the previous problem. So at period 0 itself, annuity has started. So for example, this is January 1, 2000. So for example, the account started on January 1, 2020, right? So at period 0. So that means, so at January 1, 2020, you have paid your first installment of 8,000 taka. So at February 1, 2020, you have made your second installment 8,000 taka. And like that way up to what? Up to 10 years. So up to 10 years. So the last deposit. So this is period 1, right? So the last deposit will be at period 119, because 10 years. So 10 years means 120 periods, 120 months. So similarly like before, like the last problem, 120 months, and that means 120 installments. So that means total 120 installments. Since the installment has started from period 0, so that means it will continue till 119 periods. So since it has started from period 0, here we will have 119, but total 120 installments. Now the question is asking how much will be in the account after the last deposit is made. So this is the period where last deposit is made, so that means we need to find out the future value. So future value of this annuity, so similarly like before, so here 1 plus r power t minus 1 is the formula. So C is equal to 8,000 taka divided by r. Interest rate is 7% compounded monthly. So 7% is the annual rate, 0.07. Compounded monthly means we need to divide it by 12, right? And here we will have what? 1 plus 0.07 divided by 12 power. So total 120 periods are there, minus 1. So if you calculate, the answer will be what? The answer will be, let us do it. Let me do it. So 8,000 divided by, again we need to get a fraction in the lower part of the fraction, so divided by 12. So and like 1 plus right, so we should get 1384 678 .4594 taka at the time of last deposit. So here we will get this amount of money. Right? So that means if the question, when the question asks you that how much will be in the account after the last deposit is made, the answer is this one. And after this is the period you made your last deposit, and this is the future value you will get at the time of last deposit, or after last deposit, or after maturity. But if the question asks you that how much you will get after 10 years, so if the question asks you how much you will get after 10 years, so that means if the question asks you that how much you will get after 10 years, that means after 10 years means how much will be in the account at January 1. So this is December 1 2029. So this is the period where you will make your last deposit. So on December 1 2029, on December 1 2029 you will make your last deposit. That means this is the future value you will get. This is the future value you will get on December 1 2029. But if the question asks you that how much you will get on this January 1 2030, on January 1 2030, how much we will get? So here the future value was 1, that is the future value we got 1384 678 .4594, right? This is the amount we got at this period. So this is the amount we got at this period. Now if the question asks you, since the annuity has started 1 month before, because annuity, if it was ordinary annuity, payment would have started from this period, but since it is a annuity due, payment has started from the beginning of the period. So that means payment has started from the beginning of the period. Since the payment has started from the beginning of the period, so that means you have paid your first payment from the beginning of the period. That means you have started 1 month before. So in that case, that's why annuity has completed 1 month before, right? So this is the amount you will get. This is the amount you will get at December 1 to on December 1 2029. So if the question asks you that how much will be in the account after 10 years, so if the question would have asked you to find the future value after 10 years, that we would have to find out the account balance at period t is equal to 120. That means we need to move forward. So that means we need to find out the future value here. We need to find out the future value here. So in that case, this is the single amount. We need to move this amount to this period. That means we need to move this amount 1 month forward. So we need to move this amount 1 month forward. So that means we need to move this amount 1 month forward. So in that case, future value after 10 years will be, so future value after 10 years, if the question asks you that future value after 10 years, that will be this amount 1384678.4594 multiplied by 1 plus r. R is 0.07 divided by 12. This is the value of r. So power 1, because we are moving, we will need to move 1 month forward. So we need to move 1 month forward. So we need to move 1 month forward. So which means we will multiply it by 1 plus bracket 1 plus 0.07 divided by 12. So in that case, that means this is the amount we will get 1392,755.7504 taka. So this is the amount we will get after 10 years. After 10 years. Right, so let's solve one question again. So here, let's solve this question. What do we have here? Sam wants to purchase an iPhone. Sam wants to purchase an iPhone on a 2 years EMI plan. EMI means equal monthly installment. So Sam wants to purchase an iPhone on a 2 years EMI plan where he needs to pay the first installment today. So that means the first payment or first installment will start from today. That means the beginning of the month. So the first payment or first installment will start from today. Start from today means from the beginning of the month. So this is annuity due. Cash price of the phone is 120,000 taka. Right, so if you buy the phone by paying cash, the price is this one. But you are not paying, you are not buying on a cash price. You are not buying the phone on a cash price. So you are buying it on an EMI plan. So this is the amount that will be considered as the loan amount for the EMI plan. So this is the price of the phone. This amount will be considered that you have borrowed this amount from the company to buy the phone, right? So this is the loan amount for the EMI plan. The interest rate is 14% compounded monthly. The question is asking find the monthly installment. That means what should be the EMI? Equal monthly installment, right? So first of all, let's check the time diagram. So this is period 0. This is after 1 month, after 2 months, after 3 months. That means after 1. So these are the installment amount. So the first installment will start from today. The first installment will start from today. right? The first installment will start from today, which means, so it is annuity due problem. And you have also borrowed, you are borrowing 120,000 taka today. So you are borrowing 120,000 taka today, right? So you are borrowing 120,000 taka today. So that means this is the loan amount you got today. But at the same time, you are paying C amount of cash flow installment today. So you are borrowing 120,000 taka to buy the phone from the company today. So you have borrowed 120,000 taka from the company to buy the phone today. At the same time, today itself, you are making your first installment of C cash flow. So today itself, you are making your first installment or first cash flow of C amount, right? So that means actually in that case the loan amount, so the loan amount is not 120,000 because you got 120,000 taka loan from in one hand, in the other hand you have paid C amount of cash flow to the company on the same day. So on the same day, the loan amount should be considered as the loan amount should be considered that in that case the loan, since you have borrowed 120,000 taka today from the company to buy the phone, and today itself you are paying C amount of cash flow to the company. So the actual loan, since you have paid it already today, so since you are making your C amount of cash flow, you are paying C amount of cash flow today itself, so the loan amount should be considered as 120,000 taka minus C. So the loan amount should be considered as 120,000 taka minus C. So this should be the loan amount which you need to pay off by monthly installment, which you need to pay it off by, this is the loan amount which you need to pay it off by monthly installment, right? So in that case, this is a 2 years account. This is a 2 years maturity. 2 years maturity. That means 2 years maturity means 24 installments. So 2 years means 24 installments. Two years means 24 installments. Since the first installment has started from period 0, so the last period will be 23. So since it has started from period 0, so the last period will be not 24. Since it has started from 1 month before, so it's from 0. So since it has started from period 0, the last period will be 23, right? So that means this is the present value of the loan. So this is the present value of the loan amount, or the, so here this is the cash flow you need to pay it off. So that means this is the loan amount, this is the, so we have already deducted C amount of cash flow from this 120,000. We have already deducted this C amount of cash flow from 120,000. So we have already deducted the C amount of cash flow from this 120,000 to find out the present value of the loan. So to find out the present value of the loan, which you need to pay it off by these cash flows. So these are the installment amounts. So you need to pay it off in future. So that means you need to pay off these amount of loan. You need to pay off these amount of loan by this 23 installment amount. So you need to pay off the loan by this 23 installment amount. So this is the loan amount which you need to pay it off by these 23 installments of C, right? So that means the loan amount will be, so the loan amount, that is present value of the annuity. So the present value of the annuity, so present value of the annuity is 120,000 minus C. This is the loan amount or present value of the loan, that means present value of the annuity. So present value of the annuity we know. So that's why we will use the present value of annuity formula. That's why we will use present value of the annuity formula, which is, we know that C by R minus multiplied by 1 minus bracket 1 plus R bracket close power minus T. Right? So let us multiply. So here P R is equal to C multiplied by this one. Right, so P is equal to, we already know, P is equal to present value of the loan is 120. Present value of the loan is 120,000 minus C. So present value of the loan is 120,000 minus C multiplied by R. So interest rate is 14% is the annual rate, but it will be compounded on a monthly basis. So compounded monthly, that means 0.14 divided by 12 is equal to C bracket 1 minus 1 plus R. R is this one. R is this one, bracket close, power minus T, power minus T. Minus T is equal to minus T. So 2 years, so minus T. So you need to pay off the loan. This is the loan amount. This is the loan amount which you need to pay it off by making 23 installments, because we have already deducted the first installment to find out the loan amount. Right, so in future you need to make 23 payments of C amount. So 23 installments. So 23. So power will be here minus 23, because 23 installments left. Right, so let's do it. So here what we will need to do. So first of all, what we will do is this one multiplied by this one minus this one multiplied by C, this one multiplied by this C, this one multiplied by C is equal to, that means we are multiplying these one with both of these element inside the bracket. So here what we will get, C multiplied by, let's do this calculation. Let us do this calculation. So 1 minus bracket 1 plus fraction 0.14 divided by 12, bracket closes there, power minus 23. So 1 minus 1 plus 0.14 divided by 12, bracket closes there, power minus 23 is equal to 0.23415. Right, so now let us calculate these one first. Let us calculate these one first. So 120,000 multiplied by bracket multiplied by 0.14 divided by 12, that means 1400. 20,000 multiplied by 0.14 divided by 12, that means if you multiply these one, you should get 1200. Sorry, not 1200, 1400. 1400 minus, now let us do this one. So 0.14 divided by 12. So this one we will get is 0.016667 C, and so this one is if you divide this one, you get this one, and we have C with this one, right, is equal to this one multiplied by C, that means we will get this one C, right? So let us bring all the C in the one side. So if you bring all the C in, so that means if you bring these one on the right hand side, if you bring these one on the right hand side, we will have what we will have is 1400 is equal to these one plus this one. So 1400 is equal to, let us add these two. So what we will have is 0.011667 plus 0.011667 plus 0.23415. So which means on the right hand side we will have 0.245 C, right? So the C will be 1400 divided by this one. So 1400 divided by this one. So which means, so let us do it. So 1400 divided by, so 1400 divided by 0.245817, that means 5695 5695.2936 taka. That means that means every month you should pay. So the monthly installment amount, so the EMI, so EMI is equal to 5695.293 taka. This is the monthly installment amount. So that means if you want to buy the mobile on an EMI plan, so every month, at the beginning of every month, you need to pay 5695.2936 taka. Right, so you can also do the same problem. You can also do the same problem different way. Also, right? So suppose this is period 0. Where so you need to pay your first installment. So at the beginning of first month, so you have borrowed 120,000 taka to buy the phone. You have borrowed 120,000 taka to buy the phone, and you also need to pay C amount of cash flow, C amount of EMI to pay off the loan. So at period 1 also C, at period 2 also C, and like that way. So here also C. So total 24 payments. So total 2 years 24 payments. So total 2 years, that is 24 payments. 24 months, that is 24 payments, or 24 installments, that is 24 EMI. Right? So what we can do it in other way also. Since it has started from the beginning of the period, we can, so annuity, this is an annuity due problem. So at the first, so today itself you need to pay your first installment. So that means at the beginning of the payment is made at the beginning of the period, so annuity due. So what we can do, we can convert this annuity due problem to ordinary annuity problem. How? If you bring this single cash flow to one period behind, that means where T is equal to minus 1. That means if you bring this, that means if this one is period 0, so this is minus 1. That means 1 month behind. So if you bring this cash flow to 1 month behind, in that case, that means if we assume that the EMI plan has started 1 month before, if we assume that EMI plan hasn't started from today, it has started 1 month behind. If you have assumed it like that, in that case these will be ordinary annuity in that case. So if you want to move this single cash flow 1 month behind, so in that case we will gonna use so that means since we are moving back behind, so we will use this formula. Right, see, this is a single cash flow, that's why we will use this formula. So here 100 and we are moving this amount 1 month behind. So this is interest rate is this one, power will be what? Minus 1. Why? Because we are moving 1 month behind. So if you calculate, you will get what? Let's see. So we will get is 120,000 multiplied by bracket 1 plus 0.14 divided by 12 power minus 1. So the 1 plus 0. Right. So 120,000. Right. So this is the amount. So this is the 118,616.145 taka. So that means 145 taka. So that means we can assume that we have borrowed 118,616.145 taka at period at one month before. So we can just assume that we have borrowed, so that means equivalent amount of 120,000 taka 1 month before is this one. So we can just assume that we have borrowed this amount of money 1 month before, and after 1 month, and at the end of 1 month we need to pay C amount of cash flow. At the end of 2 months we need to pay C amount of cash flow. That means we can assume that the annuity has started 1 month before, and these are the total 24 cash flows. So that means this amount is the present value of annuity. So this is now ordinary annuity because it has started. This amount is the loan amount which has started 1 month before, and after 1 month you need to pay this cash flow. After 2 months you need to pay this cash flow, and like that way total 24 payments. So now it has become ordinary annuity problem. Right. So now it has become ordinary annuity problem. So now we can easily calculate it. So that means present value of annuity is given. So present value of annuity is now this one. This is now ordinary annuity. This is the present value of the loan, and we need to pay it off by making 24 installments. Right. So this is the present value of the loan. So present value of the loan is given. So C by R, 1 minus 1 plus R power minus T. This is the formula. So here if you do cross multiplication, we will gonna have is 1 minus 1 plus R power minus T, which is P is equal to, now this is the this is the present value of the loan. So 118,616.145 is equal to C 1 minus 1 plus R is equal to 0.14 divided by 12 power minus T. Now this is 24, total 24 installments. Because why? Because now these are all the future cash flows. This is the present value of the loan, and these are all the future cash flows. So total 24 payments. So you can do it like this way also. So oops, sorry, here we need to we should have multiplied by let me erase it. So so here we should have written 118.616.118, not point. If I'm rushing, I need to go for my prayer, that's why I'm rushing. So multiplied by 0.14 divided by 12, P into R, right? So let us calculate this one. Multiplied by 0.4 divided by 12, that is, here we will get is 1338, sorry, not 38, 1383.855, and here we will get C multiplied by, let us calculate this one, 1 minus bracket 1 plus 0.14 divided by 12, bracket closes there, power minus 24. So 1 minus 4 divided by 12 minus 24, right? So it will be like 0.24299, right? So C will be 1383.855 divided by 0.24299, right? So 1383.855 divided by answer is equal to 5,695.103 taka. So this is the monthly installment amount. So this is the monthly installment amount. So previously we got also 5,695.2936. So now we got 5,695.10. So slight fluctuation is there. So it's the same amount actually. So these will be the monthly EMI. So monthly installment amount or EMI. So the EMI will be this one. So we can easily convert an annuity due problem to ordinary annuity problem and solve it in an usual way. So we can easily convert an annuity due problem to an ordinary annuity problem and solve it using the normal formula, right? So that's the end of today's lecture.